just push that up there. The second part then, so the diagram, it obviously shows an electric hand dryer, we've all used one, and AC is continuously changing direction. It's not frequent changing frequency, it's always going to be 50 hertz, and it's never going to change speed either, so it's direction. You've got some information here and here, so I've got power, I've got volts, I've got 15 seconds, okay. That throws it into the into the mix. So I'm going to use E equals PT because I've got power, I've got joules, and I've got time. And that's what it's asking me. It's asking for the energy transferred. So E over PT is going to be giving me E equals PT because I'm covering the top one, P times T. So 2,600 times 15, because 15 seconds, gives me 39,000 joules. But then, so I missed that. So I think someone from class picked this up when I was doing it in class for 6 times. Look, it's in bold. So I actually give the answer there. So now I need to times that by 6. That gives me 234,000 joules. Okay. Use the equation current equals power over voltage. It's already given you there, but if you didn't, it's in the front. PIV. I equals P over V. 2600 over 230 is going to give me 11.3 amps for that. Okay, all the information I got from here. Hand dryer is connected to the mains, which is standard 3-core cable. So that's your live, your neutral, and your earth. Complete the table below with a value of the current in each wire. All right. So the live carries the current at high voltage, and the neutral carries the current at 0 or low voltage. Since this is current, it's always the same current. So it's 11.3, 11.3 there, and 0 on the earth, because there's no fault. These figures I've got from my previous question. Oh my God, where is it? That was the first one. I think it's under there, isn't it? Is it under there? Yeah. 11.3, there it is. A fault develops in the live wire, touches the metal case of the hand dryer. Explain how a residual current circuit breaker protects the user. Well, it detects the current surge, the difference between the live and neutral. I was just talking about this on the previous bit. So the electromagnet becomes charged and excess current, and attracts the pin which breaks the circuit is what you want there. Salesperson for replacement hand dryer claims it will use fewer units of electricity each time if he uses the power at 1,300 watts when it operates, but it blows hot air for double the time. Explain if you agree. Well, I've said here that it's not true because they use the same amount of energy, even though 1,300 is half the original one, which was, let me just grab it here, which was 2,600. It's using it for double the time. Let me just clean this up here. It's using it for double the time, so you can easily work that out. E equals PT, so 30 seconds instead of 15 seconds. 15 seconds on the first page, just to prove my point. 15 seconds there. You're going to use it for 30 seconds, double the time, times the half the power, but it still comes out to 39,000 joules, which is the original one I had. 39,000 joules before I times it by 6, because it used it for 6 times. And that's that question. Okay, next question. So I need to put all those there. Again, a little bit more information here. So I've got anywhere between 220 to 240 volts. 50 hertz, anywhere between 2 kilowatts and 6 kilowatts. Made in Wales. That's the important bit there. The cooker is being used at a maximum power, 6 kilowatts, for 3 hours. Use the equation, this. So these, again, I'm going to show you. I know it's getting on your nerves, but you need to be aware where they are. Okay. If they didn't give them to you, you know they're available. So my time is 3 hours. My power is 6 kilowatts. A really simple 6 times 3 from there is going to give me 18 kilowatt hours. Use the equation cost equals units used, and that was the next one below it in my formula sheet down here. if it costs 15 pence, well, that's just 18 times 50 is going to be 270 pence. 270 pence. The cooker is connected to a fuse, and when the cooker is operating at full power, the current is 25 amps. Explain the function of the fuse and select the fuse which best suits the cooker. All right. If the current exceeds the fuse rating, it's going to melt, isn't it? And the circuit will be broken or breaks to avoid any risk, and they should use a 30 amp fuse. I'm not going to explain any more on that. And then the next question, how are we doing? 18 minutes. Yeah, this might be a 3-part video because there's a lot of questions in here. Family from Wales. Now, this question is example where it's like this question is over like 3, maybe 4 pages, but it's only worth like 12 marks. So a lot of information. The first one is 2 marks. I'm not going to read the bump. I'm just going to, from figure 1, validate the claim that PV cells could generate 3400 kilowatts annually. Well, it goes from January to December, so that is an annual term. So I'm pretty much just going to add all these up. So 50 plus 150, then March it was 250, then April it was 350. You get the idea. And that's all I've done there is added them all up to be 3,400 kilowatt hours. Leave that there. Sunshine data for Wales over the last 30 years was obtained from the Welsh Met Office, showing the mean, so the average sunshine hours for each month in Wales. Describe how this information for figure 2 supports a general trend. Well, look, it's peaking between May, June and July. And then you've got that sort of bell-shaped curve. And you've also got that bell-shaped curve here as well. So they peak between May, June and July here. So that's what I'm going to say. I've said there is an increase from January to May. Okay, just like the other graph, it peaks there and then there's a decrease from July to December. But for 1 mark, you could just get away with saying that they peak at the same times. And then state-wise, they cannot give the maximum number of sunshine hours because maximum values are misleading. Okay, you may not get those same values again. It's like someone saying to you, oh, this mobile phone always got a charge of 12 hours or 24 hours. And it really depends how much you use it for. So giving maximum values is misleading. They've got to give average values. This is part of the same question. I think in September 2015, the expected blah, blah, blah. So, right, so there's your expected. Grey, there's your dark is your actual. Use information from figure 3, so this figure, to see which ones are correct. So let's have a read through these. In December 15, this one. Oh, where are you? There it is. The actual number of sunshine hours was double the expected. Let's have a look. December. So, no, it wasn't double. It was half, actually. So that's incorrect. April 16th was the month that had the most actual sunshine hours. Well, let's have a look. April 16th. Did you? Let's have a look. So I'm looking for the dark patch. Yes, you did. Look. It's above all the other dark bars. June, July, and August have different expected sunshine hours. Let's have a look. So what does that mean? Expected. Well, there's your expected. Grey. They have different expected. So let's have a look. So June, July, and August. Well, they've all got the same. So that must be false. And then January 16th. I mean, you can see where I'm going from this. I'm not going to spend too much time, but that's false. This is true, and this is true. And then you can have a look yourselves for that. I'm not going to go through that too much. In April 16th, the PVC cells would generate 600 kilowatts. The manufacturers claimed the PVC cells could produce 3 kilowatt in sunshine. Use an equation from page 2 to validate this claim. So, what that's saying is, that's the units there, 600 kilowatt hours. What do I need to get kilowatt hours? What equation for kilowatt hours? I need power times time. And that's the equation I need. Where it's giving me the power, isn't it? Yeah, 3 kilowatts. Where do I get my time from? I'm going to get my time from there, the sunshine hours, look. And what month was it? It was April 16th. April 16th, I'm going to come across. And the actual number, actual sunshine hours was 200. And that it comes out to be, so 3 times 200 is 600 kilowatts. So I'm proving that statement there. And then the PV cells were expected to produce 3,400 kilowatts of electricity. However, the total produced was 3,670. The family saves 29 pence for each unit. So calculate the money saved. So what we need to find out is the difference between the expected and the actual. And to do that, I take away the small one from the big one. So I actually get 270 kilowatt hours from which I save. And then they pay back 29 pence for each one. So it's 29 times 270. It's going to give me £78 or 7,830 pence. If the PVC cells continue to generate more electricity than expected, what effect would this have on their payback time? So what I'm saying is, if it keeps doing that, it's going to reduce your payback time, isn't it? You're going to pay it back quickly. I may even start another video here. Oh, can I get it done? Let's have a look. The diagram below shows ring main circuit, so label them up. So how do I know the neutral is this one? Well, it's not connected to anything. In fact, the first one I would have gone for is the live wire, because I know the live wire, the outside wire, is connected to my fuse box, my MCB box. See? Oh, that's connected there. My earth wire, my dotted one inside, how do I know that's the earth wire? Because it's going to the ground. So there, look, ground. And if we follow the dotted line up, therefore my neutral wire must be the inside wire. Underline each word. So the ring main is looped in parallel. Something we just need to remember. They're thinner. They can be made thinner because there are now 2 paths for the current to flow. Am I going to do this in 2 videos? A 1.2 kilowatt kettle is plugged in. It's used for 0.5 hours in a day. Use equations. So units used equals power times time. My power was 1.2 kilowatts. My time was 0.5 hours. It's going to give me 0.6 units. And then the cost is 15 pence. 0.6 times 15, give me 9 pence. Done.